Hey everybody, it's Mr. Carr again. Today we're going to be talking about 12.8 day 2. The thing we haven't practiced yet is taking graphs and information and writing our equations out for our sine and cosine functions. Okay, so we're going to start with understanding this is our kind of general formula. We have already talked plenty of times about the period and amplitude related to the A and the B. We are not going to worry about phase shift, so don't worry about that for this video. Vertical shift is that K value, which we just did. So the biggest thing is determining the vertical shift, graphing the midline. Okay, so we understand that part. Then we want to determine the amplitude if it has something besides one. Then use dashed lines to indicate the maximum and minimum values of that function. So we mark it on our scale idea. Okay. Determine the period of the function. So we need to know that, and that will help us go into our B value there. And then we get to skip step 4. We're not worried about phase shifts. All right. So we want to write the equation of the following graph. We're going to include the amplitude period and vertical shift of this. So here's my graph right here. Okay. So again, highlight some of the key points here. First thing is look for that midline. You can see that it's going right down here. So y equals a -4, which means my k value is a -4. Okay. Then I can look at my amplitude. Going from here, going up, it's going up 2 and down 2. Whoops. So that means my amplitude A is equal to a 2, or I should say the absolute value of that. Okay, so I've got my amplitude and I got my vertical shift. Now we just need to know the period number, because as a reminder, this is how we used our period. Okay, if we know the period or we know the B value, we can figure out the period from there. But we're going to go backwards. We're going to be able to represent the period and then use that to find the B value. So let's modify this real quick. We're going to multiply both sides by B. So BP equals 2 pi. And then we divide by P here. So that B is equal to 2 pi over P. Okay. So as long as I know the period, I can figure out my B value. Okay. Remember the definition of a period. Period is going from it's one complete cycle. So if I look, for example, going from here to here, that will represent a complete cycle of my curve because I'm starting at the top, going down, and then I'm finishing up top again. Okay, so I just have to look at the differences between my two x values. So my period value can be 5 pi over 6 minus pi over 6. Gives me 4 pi over 6, which is equal to 2 pi over 3. Okay, oops, might be blocking some of that, my bad. So again, we subtracted the 2 here, get to 4 pi over 6, and we reduce that to that. Now we can use that to find our B value. So B is equal to 2 pi divided by that 2 pi over 3, okay, which is the same as taking 2 pi over 1 multiplied by 3 over 2 pi. I'm going to multiply by its reciprocal there. 2 pi's cancel each other out, so that means B just equals 3. Now, the last thing I need to do is, because I'm not 100% sure which equation I'm dealing with, look at the starting position. Since I'm starting here and going through this as like a normal setup, that's my sine function. Okay. If the graph started at the top and did it this way, like that, that would be a cosine function. So I'm going to do this in terms of sine. So y equals the amplitude A of 2 times the sine of 3 theta minus 4. Okay, and that's my equation to match this graph. Let's do one more example with like this, and that's going to be a cosine in this case. So again, we're going to write the equation of the following graph. We're going to include the amplitude, period, and vertical shift as part of our graphing. So once again, find the middle of it. It helps to know the highest point, which is 5, and the lowest point, which is -3. So if you can't quite see the midline, because it almost looks like it's the 0, but it's not in this case. So my midline, I could take 5 plus a -3 divided by 2. We're basically finding the middle of the maximum and minimum values. So in this case, the midline, it's as an equation, is 5 plus a -3 is positive 2. So y equals 1. And as a kind of a visual part of that, that's where that is. So you can see that is doing that because I go up 4 and down 4 for the amplitude idea. Okay, so we have the k value. Whoops, back to this one. My k value equals 1. My amplitude, as I just showed, is 4 because that's how far away it is going from 1 to 5 or 1 down to -3. Okay, either way, it's a distance of 4 for that amplitude. The last thing I need to do is find the b value. Again, we know that right here to right here, from 0 to pi is going to represent 1 period. So if the period is equal to 0 to pi, which is pi minus 0 is pi. So that means that my b value is 2 pi divided by pi, the period. So in this case, pi. So b just equals to 2. Again, this is a cosine setup because this is starting up top and we come down and then finish up there. Okay, so that means my equation is going to be the amplitude A, which is 4, times the cosine of 2 theta, and then plus 1 for that vertical shift. Okay, amplitude, period, vertical shift on that one. The last thing we want to talk about is putting this into a word problem and trying to interpret these parts here. So we're going to look at a wave pool. The height of water in a wave pool oscillates between a maximum of 10 feet and a minimum of 6 feet. The wave generator pumps 3 waves per minute. So then we want to write a sine function that represents the height of the water at time t seconds. Couple tricks here. Excuse me. First thing is, let's talk about, just like we did before, we want to find that midline to help us figure out any kind of vertical shift idea. So the midline is going to be right in the middle of our maximum and minimum. So that's what we're going to do here. Y equals 10 plus 6 divided by 2, which is 16 over 2, which is 8. Since the midline is the equation y equals 8, my vertical shift k value is 8. So the whole thing, the whole sine curve is moving up 8 units. Okay? Because again, midline is halfway between maximum and minimum. So we've got the k equals 8. The next thing we talked about was that amplitude. To help us with that, we're just going to take the maximum minus my midline. Okay, doesn't matter if I do 10 minus 8 or 8 minus 6 or 6 minus 8 technically, but bottom line is we get 2 for the amplitude. What is the distance from the midline up to the maximum or down to the minimum? Okay, so it also works if I did this way. The absolute value of 6 minus 8, and that would have gotten me also to 2. All right, and the last thing is to find the period. Here's where it gets a little bit tricky with our wording. 3 waves per minute. Okay, so 3 waves per minute, we want to kind of convert that into seconds. So what that means is if I do this over here, 3 waves in 1 minute, we could say 1 minute has 60 seconds in it. So we can do that. Well, if I divide by 3, that's 1, divided by 3 is 20. So what that means is we get 1 wave per 20 seconds. Okay, that is a period. It's the amount of time it takes to do 1 wave. So that is 1 full cycle. So my period is going to be treated as 20 seconds. Well, just like I did before. So this is the setup here. But personally, I'm going to use this version. B is equal to 2 pi over P. Excuse me. Okay. So that's what's going to happen. You can see the work that's being done here. But personally, I'm just going to do it as 2 pi over 20, which if I reduce that is pi over 10. Okay, and that's what I get right here. All right. So because of, excuse me, geez, I'm not going to worry about the plus or minus right now, but now we can plug it into this equation. The height of the wave is equal to the amplitude times the sine of my period. Don't worry about this. This is still that phase shift idea. So it's just, there is no phase shift in this case, plus that vertical shift with that midline. So we substitute everything in here. We do the 2 t minus 0 is just t. We can have 2 times sine of right here. 2 times the sine of pi over 10 times t plus 8. Okay. That is my simplified equation that represents the waves. And that's going to be time in seconds. And I guess I should have kept the h in there. Height. H is the height. I believe in feet. Let me just go back real quick. Sorry about that. Yes, feet. Okay. And if you want to see a quick graph of that, this is what it looks like. So again, there's that vertical shift. A normal sine function would have just done this one right here. It would have looked more like this. Yeah, didn't quite work out. But bottom line is we're shifting the whole thing up 8 units. Okay. And that is it for today. So feel free to try this problem on your own. Height of a water oscillates between a maximum of 8 feet and a minimum of 4 feet. And then the wave generator pumps 5 waves per minute. Determine the correct sine function for that one. So again, do the same process. Start with your midline. It's halfway between the maximum and minimum. Okay. Once you do the midline, do your amplitude. See how far it is from the midline up to the highest or down the lowest, doesn't really matter. And then after that, figure out from your period. The period is going to be related to the 5 waves per minute. Okay, that's it for today. Take care, everyone. See you in the next one.